these are the notes for lesson 2.4, writing equations of lines. So if we recall, we have two different forms that we've been talking about as far as equations of lines. The first is slope-intercept form, again where m is our slope and b is our y-intercept, or for graphing it's our beginning point. Standard form, we said a always has to be positive, and in standard form it's easy to find our x and y intercepts. And we're going to add one last equation, or one last way of writing equations of lines, and this is point-slope form. And actually point-slope form comes in very handy. In point-slope form, again the m is the slope as always, and x1 and y1 are just a point on the line. So x1 is just an x coordinate, and y is just a y coordinate. So to write an equation in point-slope form, we just need the slope and a point. For example 1, we're writing the equation of the line drawn. So again, we need to determine first of all which equation we're going to use, and then that will determine what information we need. So first, let's find the y-intercept and the slope. If we find the y-intercept and the slope, that means that we are finding slope-intercept form. So first we look at our graph, our y-intercept, or where our graph crosses the y-axis. I want you to go ahead and write that down first on the line. And then I want you to look at the graph. Again, remember that slope is rise over run. So I want you to find 2 points on the graph, and I want you to find your slope, your rise and your run. If you said that -3 is your y-intercept, you are correct. And for our slope, if we go up to the next point, it'll be a +6. And then we have to go to the left. Remember, if we go to the left, that means that our slope is negative. So that's a -4. So our slope, or the rise over run, is a +6 over a -4. Now if we look at our slope, we always want to simplify our slope. It should always be a simplified fraction. So 6 over -4 is the same as -3/2. And if we look at our line, you'll notice it's going down from left to right, so it makes sense that our slope is negative. So then if we're writing our equation in slope-intercept form, we then just plug in our values. So our equation is y equals m is our slope, or -3/2, x plus -3, or -3. Again, -3 is our y-intercept, so that's our b value. Our slope is -3/2, so that is our m value. So again, our equation is y equals -3/2 x minus 3. Number 2, we're finding the equation of the line below. Notice that the 2 points that they give you are -1, -1, and the other point they give us is 4, +3. Now we can easily find the slope by just doing the rise and the run. So we go up 4 and over 5. So our slope is 4 over 5. Now if they just gave us these 2 points and they did not give us the graph, we could easily find the slope by using the formula that we talked about before. So y2 minus y1 over x2 minus x1. Now since they show us the graph, we can easily look and find the rise over run, but again, if we were to plug in those points, we would get the same number for the slope. Now this one I want to write in point-slope form. Remember, point-slope form is y minus y1 equals m, or the slope, times x minus x1. So we already found the slope, and the only other thing we need for point-slope form is a point on the line. So it does not matter which point we use. Since I like to work with positive numbers, I'm going to use the point 3. Remember, this is an x value and a y value. So all we're going to do is plug these things into our equation. So we have y minus, y1 is simply our y value for our point. So in this case, it is 3. M is 4/5, because that is our slope. And then we have x minus, and then x1 is just our x value, which is 4. So the equation of this line is y minus 3 equals 4/5 times x minus 4. And that is the equation of the line. So again, we could find the y-intercept and we could do slope-intercept form, or we can use point slope and just use a point on the line and the slope to write our equation in point slope form. Example 3 says to write an equation of a line that passes through the point -3, 4 and has a slope of 2/3. So in this case, they don't show us the graph, but they give us information that would be on a graph. So again, we know that slope-intercept form is y equals mx plus b. We also know that point slope form is y minus y1 equals m times x minus x1. And these formulas will come in handy when we're writing our equation. Now, if we look at the information that they give us m, which is our slope, and they also give us a point on the line. So if you look at slope-intercept form and point slope form, which of these forms is going to make the most sense if we're given a point and the slope? If you said point slope form, you are correct, because all we have to do is plug in our slope and our point. So if we start with y minus, our y1 is our y value. So if we look at our coordinates, -3 is x, 4 is y. So we just plug in 4 for y1. And that equals m, which we know is our slope. So this is 2/3. And then x minus, again, -3 is our x value. So we get y minus 4 equals 2/3 times x plus 3. Now I want you to write this in slope-intercept form. So I want you to change it to slope-intercept form, which you will usually be asked to do. So in order to change this to slope-intercept form, we first want to get rid of our parentheses. So if you remember from chapter 1, we distribute. So this gives us y minus 4 equals 2/3 x plus, now look for a second, we have 2/3 times 3. This is the same as 2/3 times 3 over 1. Our 3's cancel out and it just equals 2. So this is 2/3 x plus 2. Now again, in slope-intercept form, we want y by itself. So we also want to add 4. And then that should get us into slope-intercept form. So y equals 2/3 x plus 6 is our equation in slope-intercept form. So again, if they give you a point and the slope, the fastest way is just to plug it into point slope form, and then we can change it into slope-intercept form from there. Now, if you recall from the previous section, parallel lines have the same slope. So we know that if we have parallel lines, then their slopes are the same. Perpendicular lines have, you said opposite reciprocal, you are correct. So again, parallel lines, same slope. Perpendicular lines, opposite reciprocal slopes. So we can use that information to, again, write equations of lines. So example 4 says to write the equation of a line that passes through the point 2, -3, and then it is parallel to y equals 2x minus 3. So again, we need two pieces of information in order to write an equation. We need a point and we need the slope. Now, since we know that this line is parallel to y equals 2x minus 3, we know that the slope of this line is our m value, which is 2. And since it's parallel, our slope also has to be 2. So if we have a slope of 2 and we have the point 2, -3, we can plug that into point slope form. So we have y minus our y value, which is -3, equals our slope of 2 times the quantity x minus 2, because again, 2 is our x, -3 is our y. Like we did before, we want to distribute. Y minus a -3 is the same as y plus 3. If we distribute, we get 2x minus 4. And then again, we want y by itself. So we subtract 3. So our final equation is y equals 2x minus 7. So the equation of the line that passes through the point 2, -3 and is parallel to y equals 2x minus 3 is y equals 2x minus 7. Again, we know that these lines are parallel because they have the same slope. They both have a slope of 2. And notice they have different y-intercepts, which we talked about in the previous section. Example 5 says to write the equation of a line that passes through the points 4, -6 and 2, -4. So notice in this case they give us 2 points. Now before we can write an equation, we know that we need the slope. So we first need to find the slope. I want you to think back to the first section, and I want you to write down the formula that we use to find the slope if we're given 2 points. So the equation to find slope if we're given 2 points is y2 minus y1 over x2 minus x1. So the first thing we need to do is use this formula to find the slope. So again, I'm going to do x1, y1, x2, y2. So y2 is -4. So -4 minus -6. Then I have 3 minus 4. Remember, subtraction is the same as adding the opposite. So my numerator is going to be 2. My denominator is -1. Now 2 over -1 is just -2. So our slope is -2. Now in order to write an equation, we need a slope and we need a point. So the next thing we need to do is to pick a point. They gave us 2. They gave us 4, -6 and 3, -4. It does not matter which point you pick. So we're going to pick one of our points, either 4, -6 or 3, -4, and we're going to plug that in our slope into point slope formula. I'm going to use the first point. If we had one point that had positives and one with negatives, I would choose the positive ones just because it's easier to work with positive numbers. But since they both have a negative coordinate, it really doesn't matter which one you choose. You'll end up with the same answer either way. So y, we're going to plug in 6 is our y1 value. So minus a -6 equals our m, or our slope, is -2. And then x minus 4, because 4 is our x1 value. Again, we're going to simplify and solve for y because we want to write it in slope-intercept form. We can add that to our list of steps. We're going to use point slope to write our equation. So y minus a -6 is the same as y plus 6. If we distribute, we get -2x plus 8. Notice we have a negative and we're subtracting. Negative and negative means plus. And then we're going to get y by itself, so we're going to subtract 6. So y equals -2x plus 2 is our final equation. So again, whenever we are given 2 points, we first want to find the slope using that formula we talked about before. Plug it into point slope form using whichever point you want, and then simplify or change it to slope-intercept form. And our last example, again, we're applying this to real-life situations. So in 1984, Americans purchased an average of 113 meals of snacks at restaurants. By 1996, this number was 131. Write a linear model for the number of meals or snacks purchased per person annually. Then predict the number of meals that will be purchased in 2006. So the first thing we need to look at is what information we are given. We know that in 1984, we had 113 meals. We know that in 1996, we had 131 meals. So this is going to become our 2 points. So 1984, the time and the meals. And then we know that in 1996, we had 131 meals. So now we have 2 points. Now we want a linear model. So in order to have a linear model, we need the slope and we need a point. We need those 2 pieces of information. Now, since they gave us 2 points, we can find the slope. Again, write down the formula that we use. And let's plug it in. So y2, which would be 131, minus y1, which is 113, over x2, which is 1996, minus x1, which is 1984. We subtract these, we get 18/12. And we can divide both of those by 6 to get 3/2. So our slope is 3/2. Then to write a linear model, again, we need the slope and a point. So we can pick either one of these points to use. I'm going to use the first one just because it's written first. It really doesn't matter which one you use. So we're going to plug that into point slope form. So again, this is step 1, finding the slope. Step 2, we're plugging it in. So y minus our y1, again 113 is our y value, equals, our slope is 3/2, and we have x minus our x value, which is 1984. And then again, we want to write this in slope-intercept form. So we're going to distribute. We have y minus 113 equals 3/2 x minus, we multiply 3/2 times 1984, you should get 2,976. Then lastly, we're going to add 113 to both sides. So our final equation is y equals 3/2 x minus 2,863. So that is our linear model that they asked for. So that's the first part of our answer. Now the second part asks us to predict the number of meals that will be purchased in 2006. So we're going to use this equation that we just found, and we're going to find how many meals were purchased in 2006. So if they give us the number 2006, remember that is time. And remember that x is our time. So if we look at our points, both of our time numbers are in the x place. So we're going to plug in 2006 for x. So y equals 3/2 times 2006 minus 2,863. And that should give us our y value. If we plug this in, we should get y equals 146 meals. So in 2006, they should have 146 meals, or have purchased 146 meals. So again, we can use points, we can use linear models to predict what is going to happen in the future.